Hey guys, in this video we're going to continue our discussion on compound interest with 3 example problems. Now, to review, as discussed in the prior video, the compound interest formula is composed of 3 values that we're going to take into consideration when calculating it. These values are P, the principal amount, or the initial amount of money that you begin the investment with, I, the periodic interest rate, and N, the number of periods. So for this first example, we're going to consider 3 cases where the periodic interest rate varies dependent upon the number of times we compound per year. In case A, we are compounding once per year because it is saying that we are compounding annually. Also, remember, as stated in the beginning of the problem, that our P, our principal amount, is $5,400, and our I, our periodic interest rate, or at least part A, is 8%. So if we write out this formula, we get A equals P, which is $5,400, times 1 plus I. Now, I should be expressed as a decimal. So we're going to express 8% as a decimal, 0.08, and then N is 2, because it's compounded annually, which means once a year for 2 years. So that's 2 periods total. And after simplifying, we get this value. And then after solving for this, we get our answer, $6,298.56. Now for part B, we have a couple of things that are going to change. The first thing that's going to be different than part A is the number of periods, since we are dealing with a problem that is now saying we are compounding semi-annually, which means twice a year. So if we're compounding twice a year for 2 years, the total number of periods would be 4. So N is going to be 4 in this case. And I, the periodic interest rate, is no longer simply going to be 8%. If that occurs twice a year, we're going to divide that 8% by 2 to get I equals 4%, or 0.04 as a decimal for this problem. So our equation is going to be A equals 5,400 times 1 plus I, which is 0.04, to the 4th power. This gives us 5,400 times 1.04 to the 4th power, which yields the correct answer, $6,317.24. Now for the third problem, we are dealing with, again, yet another way to compound the interest rate and to calculate the number of periods. Since the problem states compounded quarterly, we know that we're going to have an N value that is dependent on that quarter amount, which is 4, and the number of years too. So N is going to equal 2 times 4, which is 8. Also I, our periodic interest rate, is going to be that 8% value, however, divided by 4 this time. So it's going to be 0.02. So our equation for the total amount is going to be 5,400 times 1 plus 0.02 to the 8th power. We simplify and then we solve, and we get our final answer of $6,326.96. For problem 2, we're going to take a look at how the simple interest formula compares to the compounded interest formula. So we have Carmen invests $9,000 into a retirement fund that pays 4.2% interest. Round your answers to 2 decimal places. So for part A, we compare the value of the fund after 25 years if the interest is simple interest. So simple interest is how it sounds, much more simple of an equation to work out, because R is going to be the interest rate, which in this case is 4.2%. However, we need to express this as a decimal. And T, which is the time, which in this case is 25 years of time. So T equals 25. And we get for the amount equals the principal, which is $9,000 times 1 plus the rate times time. And after working all of this out, we're going to receive the answer of $18,450. Now, how does this compare to the option of compounding it quarterly and not using simple interest? Well, that's a very interesting question, and we want to see if we're going to be making more money or less money on our investment if we're compounding quarterly. So let's take a look at that. Well, we know that N is going to be the number of periods. Compounded quarterly is referring to compounding it 4 times a year, but this is happening for 25 years. So 4 times 25 is 100. So the number of periods is 100. Also, I, our periodic interest rate of 4.2%, is divided by 4 because it's happening 4 times a year. So we're going to take that 0.042% and divide that by 4. and we get a value of 0.0105. And then we find the total. The amount equals 9,000 times 1 plus I, 0.0105 to the 100th power. And after simplifying, we get 9,000 times 1.0105 to the 100th power. And after working this out, we see the answer of $25,578.45. A considerable amount more than if we were simply using the simple interest model. And for this last problem, we're going to analyze 3 cases that will just give us a little bit more experience and practice with calculating these compound interest types of problems. So the important thing to remember are the 3 parts that we need to focus on, which are the principal amount, the periodic interest rate, and the number of periods. So for part A, we know that the principal amount is $1,300. The I, which is the interest rate, is 10% as a decimal, which is 0.1. And N is the number of periods. So we're compounding annually, so that's once a year, but we are trying to find the amount after or at the end of 3 years. So we're going to have 1 times 3, which is 3, so N equals 3. So putting that all together, we get A equals 13,000 times 1 plus 0.1 to the 3rd power. That's 13,000 times 1.1 to the 3rd power. And we get our final answer, which is $17,303. Now, if we're going to compound semi-annually, that means that this is going to affect both I and N. P still remains the same, because P is the amount that we begin with. I, on the other hand, is not going to be now 10%, it's going to be half of that because this is occurring twice a year, hence the word semi-annually. So we're going to take 10% and divide that by 2, so it's 0.1 divided by 2, which is going to be 0.05. And N, the number of periods, is also going to change because we are having 2 occurrences per year for 3 years. And 2 times 3, well, that gives us 6. So our equation is A equals 1,300 times 1 plus 0.05 to the 6th power. That's 1,300 times 1.05 to the 6, and that will yield our result of $17,421.24. And for the last problem, quarterly, which is 4 times a year, will affect both our I and N, but again, not our P, not our initial invested amount, which of course is 13,000. I will be the 10% interest rate divided by 4, so 0.1 over 4, which would be 0.025. And N, since it is occurring quarterly, 4 times a year for 3 years, will be 4 times 3, which is 12. So A, our amount is 13,000 times 1 plus 0.025 to the 12th power, which is 13,000 times 1.025 to the 12th, yielding the solution of $17,483.55. There you have it, guys. That's the compound interest formula and the simple interest formula and how to utilize those in problems that you see in your math book.